Alaikum, hello, hi. Today we study chapter number 4, the derivative in graphing and application. Exercise 4.1. In exercise 4.1, we study analysis of function, increases, decreases, and concavity. So first of all, what is increasing and decreasing function? The term increasing, decreasing, and constant are used to describe the behavior of a function as we travel left to right along its graph. Let's suppose we have a graph of increasing, decreasing, and constant function. So point 1 is we have different points 0, 2, 4. Now we draw a graph. So you can see that as we travel left to right, so left left side of the 0 we have the increasing function. Now as we move from 0 to 2, so you can see that we have the decreasing function. And similarly 2 to 4 we have an increasing function, and as we move right side of the 4, so we have constant function because not increasing function, not decreasing function. So this is our increasing and decreasing function. And one thing more is that if function is increasing, so we have positive slope, and if function is decreasing, so we have negative slope, and constant function have zero slope. Now go to the question. Let's suppose we have a function f of x is equal to x square minus 4x plus 3. Now for the points of take first derivative. If we take derivative, so we have 2x minus 4. Now put first derivative equal to 0, so 2x minus 4 is equal to 0. Now find the points. If we take common, so we have x minus 2 equal to 0, or overall we have x is equal to 2. So this is our point x is equal to 2. Now check it on the region for increasing and decreasing function. This is our point x. Let's suppose 2. This side we have minus infinity, and this side we have plus infinity. For increasing and decreasing function, if we put less than 2 in a function, derivative function, so what we have, let's suppose we put 1, 4, so we have a negative value, means that function is decreasing from minus infinity to 2. Function is decreasing from minus infinity to 2. And if we put greater than 2, let's suppose 1, let's suppose 3, so we have positive value. So function is increasing from 0.2 to plus infinity. F is increasing from 2 to plus infinity. So graphically, if we draw the graph of this function, we have other points. Let's suppose this point is 2, this point is 3. So you can see that if we move travel left to right from this point to this point, our function is decreasing, and if we travel left to right from this point to this point, our function is increasing. So this is increasing and decreasing function. For next topic is concavity, and there is two concavities, concave up and concave down. So what is concave up? A function is concave up on an open interval if its tangent line have increasing slope. Let's suppose we have graph of concave up, x-axis, y-axis. This is the shape of concave up. So first point is that function is concave up on an open interval if its tangent lines have increasing slope. So what is tangent line? Let's suppose we have a circle or half circle. A line touches at the end of a circle is called tangent line. This is half circle. This line is called tangent line. So let's suppose we have a tangent lines. So you can see that tangent line is increasing. So this is concave. The other point is that f is concave up on an interval if its graph lies above its tangent line. So you can see that this graph is lies above on the tangent line. So this is concave up. For concave down, first point is that the interval is concave down if they have decreasing slope. Let's suppose graph on x and y axis. So this is concave down shape. So you can see that in this graph we have decreasing tangent line slopes, and the other point is that the tangent and concave down if it lies below tangent line. So you can see that this graph is dropped below tangent line, so this is concave down. An example, we have f of x is equal to x cube minus 3x square plus 1. In this function we discuss increasing, decreasing and concavity of a function. That is, for increasing and decreasing function, take derivative. We have 3x square minus 6x. For points, for f of derivative x is equal to 0, so we have 3x square minus 6x is equal to 0. Take 3x common, so we have x minus 2 is equal to 0. 3x is equal to 0 and x minus 2 is equal to 0. X is equal to 0 and x is equal to 2. So these are the point down a region: minus infinity, plus infinity, 0, 2. Now check it out, increasing and decreasing function. If we put less than 0 in a function, if we put minus 1 in a function, so we have 3 minus 1 square. We have a positive value, so function is increasing. Function is increasing from minus infinity to 0. If we put in between 0 and 2, let's suppose 1. So we have a negative value. It means that function is decreasing from 0 to 2. If we put greater than 2, let's suppose 3 in a function, so we have positive value. So function is also decreasing from 2 to plus infinity. So we have minus infinity 0 union 2 plus infinity, because function is also increasing at these points. So this is the increasing and decreasing function. And for concavity, take double derivative of the function of this function. So we have 6x minus 6, and for points put double derivative equal to 0. So we have 6x minus 6 is equal to 0. Overall we have x is equal to 1. Now check it out on the region. It's minus infinity, plus infinity. If we put less than 1, let's suppose 0 in a double derivative function. So we have negative value. It means then function is concave down from minus infinity to 1. This sign is for concave down. Function is concave down from minus infinity to 1 because we have a negative value. If we put greater than 1, let's suppose 2. So we have a positive value. It means then function is concave up from 1 to plus infinity. And if we draw the graph of a function, so we have the graph of a function. So different points, let's suppose this point is minus 3, minus 1, minus 1, 1, 2, this point is 1. So one thing more in this graph is that is point of inflection. So what is point of inflection? From the point from which concavity is changed. Means concave up is changed to concave down, or concave down is changed to concave up. You can see in the graph at this region we have a concave down for this point. So this is the point of inflection, because this point the concavity is changed, we have a concave up shape. So this is the point of inflection from which concavity is changed. Now we go to the exercise, starting from question number 15. F of x is equal to x square minus 3x plus 8. Now in question number 15 to 37, they are asking us find the intervals on which f is increasing. A point, B point is that the intervals on which f is decreasing. C, the upper intervals on which f is concave up. D point is that the open intervals on which f is concave down. Now for increasing function and decreasing function takes single derivative. So we have 2x minus 3. Now for points put f of single derivative is equal to 0. We have 2x minus 3 is equal to 0. We have x is equal to 3 by 2. Draw in a region. But this is 3 by 2 minus infinity plus infinity. Now put less than 3 by 2. Now I can put in the function minus 1. If we put minus 1, so we have a negative value. Which means then function is decreasing from minus infinity to 3 by 2. Function is decreasing minus infinity and 3 by 2. If we put greater than 3 by 2, let's suppose 2 or 3. Let's suppose put 3. So you can see that we have a positive value. It means then function is increasing from 3 by 2 to plus infinity. And for concavity, take double derivative of the function. Double derivative of function is 2. It is a constant value. So we don't have a concave up or concave down because it is a constant value. We can't put it on a region. So next question is question number, we try question number 17. F of x is equal to 2x plus 1 cube. So first step is that take single derivative. So we have for the point of x, put f derivative x is equal to 0. So we have 6. We have a point x is equal to minus 1 by 2 minus infinity plus infinity. If we put less than minus 1 by 2, so I put minus 2 in a function. 6 2 minus 2 plus 1 square. So we have a positive value. It means then function is increasing from minus infinity to minus 1 by 2. If we put greater than minus 1 by 2, let's post 2 or 1. If we put 1, so we have we also have a positive value. This means then function is also increasing from minus 1 by 2 to plus infinity, and function is cannot be increasing because we can't have a decreasing points. And for concavity, take double derivative x x plus 1. We put double derivative is equal to 0. So we also have x is equal to minus 1 by 2. If we draw on a region, so we only have a, let's suppose if we draw minus 1 by 2, infinity, less than infinity. We put less than minus 2, so we have a positive value, and if we put greater than minus 1 by 2, so we also, if we put less than in a function, let's suppose minus 1. So we have a negative value, it means then function is concave down from minus infinity to minus 1 by 2. And if we put greater than minus 1 by 2 in a function, so we have, let's suppose we put 2 in a function, you can see that if we saw that we have positive values, means then function is increasing from minus 1 by 2. Function is concave up from minus 1 by 2 to plus infinity. Next question is question number 20. F of x is equal to x4 minus 5x cubed plus 9x squared. Take double derivative of single derivative of a function, so we have 4x cubed minus 15x squared plus 18x. Put function is equal to 0, x cubed minus 15x squared plus 18x is equal to 0. Take x common, so we have 4x squared minus 15x plus 18 is equal to 0, so x is equal to 0 and 4x squared minus 15x plus 18 is equal to 0. Apply quadratic formula, so x is equal to 15 plus minus 15 square 4 x is equal to 15 plus minus 225 minus 288. Minus 63 means imaginary value. We can't take imaginary value, so we only take x is equal to 0. Now draw x is equal to 0 on a region. If we put less than x is equal to 0, let's suppose 1 in a function. So we have 4 minus 1 cube 15 minus 1 square. So we have a negative value, it means then function is decreasing from minus infinity to 0. And if we put positive value, let's suppose 1 in a function, so we have 4 minus 15 plus 8. If we solve that, so we have we have a positive value, it means that function is increasing from 0 to plus infinity. For concave and concave down, take double derivative. For double derivative is equal to 0 for points of x. Take 2 common, so we have here take also 3 common, so we have 2x square minus 5x plus 2 is equal to 0. Overall we have 2x square. So apply quadratic formula. These are the 2 points, x is equal to 2 and x is equal to 1. X is equal to 1 and x is equal to 2. We will put in a region 1, 2, minus infinity, plus infinity. We will put less than 1, let's put 0 in a function. So we have a positive value, means function is in concave of from minus infinity to 1. Function is concave of from minus infinity to 1. If we put in between 1 and 2, let's suppose 1 by 2. So we also have a positive value, then function is also concave of from 1 to 2. If we put greater than 2, let's suppose 3 in a function, 9, 90 plus 8, 12, 9. So we also have a positive value, it means then function is also increasing from, function is also concave of from 2 to plus infinity. So that's it for today. If you can't attempt any question from this exercise, contact us on Facebook and Insta. And for more information, also follow us Facebook and Insta. The link of Facebook page and Insta page is in description.